So we are looking at the introduction to algebra. Algebra is the use of symbol or alphabet to represent numerals. A letter of the alphabet can be used to represent a number, a collection of numbers, when the specific number is unknown. And because the number is unknown except to the person who thought of it, we shall represent the number by an alphabet. Example. A, B, C, D, alpha, beta, gamma, phi, omega. So these ones are known as constants. Each of it represents a particular number that cannot change. First of all, a constant is a number that cannot change. And here, one of these things now represents a particular number that cannot change. That's why it's a constant. And we have variables. Examples of variables are V, W, X, Y, Z. These ones are variables. Each of these represents a collection of numbers or a group of numbers. And variables can change. Why it changes? Because when we are bringing out those numbers that are represented by this, you will see that those numbers are not equal. So as you are bringing out those numbers, the values will be changing. So that's why this is variable. So now let's take this exercise. So this is the algebraic expression. So exercise. First, think of a number. Add 3 to it. Double the result. Now, add the number you first thought of. Divide the result by 3. Take away the number you first thought of. And the result is 2. Then why? So looking at these things now, they say here, think of a number, and the number is not given. And since it's a number, that means it's a particular number that cannot change. Thereby, you represent it with constant. And constant is any letter of the alphabet, starting from the beginning of the alphabet, is a constant. So let's take B. For instance, let's take B. B is the number we are asked to think of. Then add 3 to it. So we say B plus 3. And the third one here says double the result. So now when we ask to double the result, so what we'll do now is enclose this one in a bracket. Then times 2. Add the number you first thought of. But before then, let's solve this one out. So here now we say equal to So here 2 times b plus 2 times 3, that will be equal to 2 times b plus 6. So here, add the number you first thought of, and the number we first thought of is b. So 2 times b plus 6 plus b. So if you look at it, you see that you notice that there is b here and there is b here. So you carry this one to the right hand, and that will be equal to 3 times b plus 6. Here it said divide the result by 3. So 3 times b plus 6. You divide all this by 3. So you have to enclose it in a brace. Divide by 3. And that will be equal to 3 times b over 3 plus 6 over 3. So now we notice that they have common denominators. So because they have common denominators, that will be equal to 3 times b plus 6 all over 3. So 3 here will divide 3 here. That is equal to 1 times b. And 1 times b is b. So this 3 also will divide this 6. That this 6 will be divided by this 3. That will be equal to b plus 2. So, and the last thing here, take away the number you first thought of. And the number we first thought of is b. So we are going to take away. You are asked to think of a number, and the number is not given. So since the number is not given, and it's talking of a particular number, so that number will be constant. And since it's not given, except to the person who thought of it, so let's represent the number with b. So let's say b, and they say add 3 to it. So we say b plus 3. And the second thing, they say double the result. So now double the result is, before we double the result, we have to include this one in a bracket. For it to be b plus 3 times 2. So that will be equal to 2 times b plus 2 times 3. So it will be equal to 2 times b plus 6. That's 2 times b plus 2 times 3, which is 6. Now, they say add the number you first thought of. And the number we first thought of is b. So we say 2 times b plus 6 plus b. And that will be equal to, because if you look now, you see that we have b here and we have b here. So we carry this to the right hand. So that will be equal to 3 times b. Because 2 times b is 2b. 2b plus b is 3b. And 3b is 3 times b. So plus 6. And the next thing, they say divide the result by 3. So we have 3 times b plus 6 divided by 3. So we have to cover it up like this, so that this 3 will multiply everything in this bracket. So that will be equal to 3 times b over 3 plus 6 over 3. But before then, let's see. 3 times b, that's this, plus 6, which is this, all over 3. So they have common denominator, that's why it's like this. But before we control, let's split them. So 3 times b over 3 for this plus 6 over 3. So this 3 will go against this 3. That 3 divided by 3 is 1. And 1 times b is b. So we have b there. Plus 6 divided by 3 is 2. We have b plus 2. And then last thing, they say, remove the number you first thought of. So a number you first thought of is b. So since we have b plus 2, and we are removing the number we first thought of, so b plus 2 minus b will be equal to 2. So this is our result. So this is a demonstration of how an unknown number can be represented by a letter of the alphabet, which can then be manipulated just like an ordinary numeral with an arithmetic expression. You know, the same way we use arithmetic expression to manipulate numerals, you can also use it on the letters of alphabet. So if A and B represent 2 unknown numbers, then we speak of the first one, sum of A and B. Sum of A and B as A plus B. So the same way we use this plus sign on numerals, so we also use it on the letters of alphabet. Secondly, if A and B represent 2 unknown numbers, then we speak of difference of A and B as A minus B. If A and B represent 2 unknown numbers, then we speak of the product of A and B as A times B, or A dot B, or AB. A times B and A dot B, they are the same thing, and AB is a short form of writing A times B. Then the fourth one, if A and B represent 2 unknown numbers, then we speak of the quotient. We speak of the quotient of A and B as A divided by B, or A D, or this way, provided that B is not equal to 0. Then the fifth one, if A and B represent 2 unknown numbers, then we speak of the exponent. We speak of the exponent of A and B as A raised to the power of B. Exponent also means raising to the power. So A is raising to the power of B. That means A will multiply itself in B places. Example, assuming that B is equal to 3, and the A is raising to the power of B. So A raised to the power of B will be equal to A raised to the power of 3, which will be equal to A times A times A times A. So A will multiply itself in B places. So let's look at this place now. A times A times A times A times A times A. 1, 2, 3, 4, 5, 6 will give us A raised to the power 6. Because A multiplied itself in 6 places. Now A plus A plus A plus A plus A plus A. We have A plus A, 2A, plus A, 3A, plus A, 4A, 5A, plus B, 6A. We want to 6 times A, which we want to 6A. And here we have A plus A plus A plus A minus A minus A. So, looking at this here, you notice that we have both plus sign here and minus sign here, and all these things are A. So all you do now is just cover this one in bracket. 4A. So here now, if you look at this now, you see that this minus sign is for these ones, all these things in this bracket. So you use this minus sign to multiply these things here. So minus times A will give you minus A, and this will give you minus A. But you won't do it like that. What you will do now is say minus times minus is plus. So what we have here now is A plus A, 2A. That will be minus 2A. So 4A minus 2A is equal to 2A. So here we have 18A divided by A. So 18A divided by A will be equal to just as 18 times A divided by A. You cannot say 18 divided by A. So what you do now, you use A to divide the last term. So A divided by A. So what will be left is 18. Here is what we are going to look at now is constants and variables. So in our first work, we saw how we use a letter of the alphabet, that's the letter D, to represent a number. So something is known as constant. So examples of constants are, for example, before that, constants are those numbers or values that cannot change, and they are represented with the letters of the alphabet. All the letters from the beginning of the alphabet, we use them to represent constants. Examples are A, B, C, D, and so on. These are constants. So each of these represents a particular number. For example, if A is equal to 3, A will remain 3. It cannot change. If B is equal to 4, B will remain 4 and cannot change. And if C is equal to 5, it will be 5 and nothing will change it. And if D is equal to 10 and so on, that's how it will be. But for variable, variables are not the same with constants. Variables are those values that can change. And the variable, these are examples of variables. They are letters from the end of the alphabet, used them to represent variables, and each of it represents a collection of numbers. And when we enter those numbers, you will notice changes because all the numbers are not equal. For example, V here, V can be equal to even numbers between 1 to 10. W can be odd numbers between 1 to 10. X can be prime numbers between 1 to 10. So these are variables. So if you look at this pattern, you notice that we have more than one number here, more than one value. So even numbers are 2, 4, 6, 8, 10. So as I'm bringing those numbers out, you notice changes. So all of them are not equal. So 2 is not equal to 5, 4 is not equal to 6. So a variable can change, but constant cannot change. Constant remains as it is. So another example is X is equal to the age of 20 students in a class, whereby Y can be equal to the height of 20 students in a class, and Z can be equal to the weight of 20 students in a class. So that is the difference between constant and variable. Each of the constants is made for one particular number. But for here, each of the variables is made for a collection of numbers, or a group of numbers. So that is. And in many other problems, a symbolism is required to represent a collection of numbers when the specific number is unknown. So that's what brought about the idea of variable. So we are looking at the rules of algebra. The rules of arithmetic for integers also apply to any type of number, and they express this fact in the rules of algebra, where we use variables rather than numerals as specific instances. The rules are commutative. This is where we add or multiply x and y in any order without affecting the result. For example, x plus y is equal to y plus x, because if x is equal to 3 and the y is equal to 2, then 3 plus 2 is equal to 5, and turning it to the other side, 2 plus 3 is also equal to 5. Therefore 3 plus 2 is equal to 2 plus 3. Therefore, x plus y is equal to y plus x. So, in this we say that the rules of algebra is commutative using a plus sign. Then let's look at multiplication. X times y is equal to y times x, because assuming x is 3, so 3 times 2 is equal to 5, and the 2 times 3 times 2 is equal to 6, and 2 times 3 is also equal to 6. Therefore 3 times 2 is equal to 2 times 3. Therefore x times y is equal to y times x. So because of this, we say that multiplication and addition are commutative, meaning that the order of arrangement does not affect the results. Now let's look at the subtraction. The order in which two numbers are subtracted, the order in which two numbers are subtracted or divided can affect the result. The order in which two numbers are subtracted or divided can affect the result. Example: x minus y is not equal to y minus x, because if x is equal to 3 and the y is equal to 2, then 3 minus 2 is not equal to 2 minus 3. Therefore, the operation of subtraction and division are not commutative, except on special cases. Now, let's go to division. X divided by y is not equal to y divided by x. Because of this, we say that the operation of division is not commutative, because if x is equal to 3 and the y is equal to 2, then 3 divided by 2 is not equal to 2 divided by 3. Therefore, we say that the operation of subtraction and division are not commutative except in special cases. Unless y is equal to x, or x is equal to y. So this is associativity. This is the second rule of arithmetic operation after commutative. Now, he said the way in which the numbers x, y, and z are added or multiplied does not affect the result. Example: x plus y plus z is equal to x plus y plus z. So if you look here now, you notice that x is outside the bracket, while y and z are inside the bracket. Here, x and y are inside the bracket, while z is outside. So the order of the arrangement does not affect the result. That's what they are telling us in associative. Now, So let's look it out. Because if x is equal to 5 and the y is equal to 3, if x is equal to 5, y is equal to 3, and z is equal to 2, therefore, then x plus y plus z is equal to x plus y plus z, because x is 5, so we have 5 here, plus then inside the bracket we have y as 3 plus z as 2, and let's solve the ones inside the bracket first. So 3 plus 2 is 5 plus 5, that will give us 10, and if we have our x and y inside, but just like this now, this one is this, and this one, let's look at this one now, see what it will be. X is 5 inside the bracket plus y is 3 inside the bracket plus z, which is 2 outside. So we have it to be 5 plus 3 equal to 8 plus 2, that is equal to 10. So that is it here. Therefore, the operation of addition is associative. So let's look at multiplication. Let's look at multiplication and see if multiplication is associative. Good. There we have x times y times z. Or let's do it this way. X times y times z. And then x in bracket times y times z outside the bracket. So we want to see whether this is equal to this. So if this can be equal to this, that means multiplication is associative. So, example, if x is equal to 5, y is equal to 3, and z is equal to 2, then x will be 5 times 3 times 2. So 3 times 2 is 6. That will be 5 times 6. So 5 times 6 is equal to 30. So let's look at this side. If x is equal to 5, y is equal to 3, and the z is equal to 2. So x times y is equal to 5 times 3. We are still under associativity. So here, we want to see whether the way in which two numbers are subtracted or divided, whether it can affect the result. So here, if you look at it, you see the way in which the numbers are associated under subtraction and division does affect the result. Example. Example here. So let's see. X minus y minus z, and also we have in bracket x minus y minus z outside the bracket. So I want to see whether these two things can be equal. If they are equal, that means their association does not affect the result, or they are under of arrangement. But if they are not equal, that means they are not associated, under associative. So, example here. If x is equal to 5, y is equal to 3, and z is equal to 2, then 5 outside the bracket minus 3 minus 2 in bracket. So here you see that 3 minus 2 will give us 1. Then 5 minus 1, that is 5 minus 1 will give us 4. And let's look at this one now. If x is equal to 5, y is equal to 3, and z is equal to 2, then x minus y in bracket will be 3 minus 2 in bracket, then minus 5. Sorry, x is equal to 5. So that's 5 minus 3 in bracket minus 2 outside the bracket. So 5 minus 3 is equal to 2, and 2 minus 2 is equal to 0. Therefore, x outside the bracket minus y minus z in bracket is not equal to, in bracket, x minus y minus z outside the bracket. Hence we say that subtraction is not commutative. So let's look at division. Here we have x divided by y divided by x divided by z in brackets. So and again we have in bracket x divided by y, and outside the bracket divided by z. So I want to see whether these two things can be equal. So let's see here. Example. If x is equal to 5, y is equal to 3, and z is equal to 2, then, so we are looking at this one. Then 5, first of all, x divided by y, y divided by z. This is distributive. We are on distributivity. So we want to look at multiplication and division, how they are distributed over addition and subtraction. So let's take multiplication first. Now, multiplication is distributed over addition and the subtraction from both the left and the right. So let's look at the left hand side. Example. First of all, we want to look at the left hand side. So we have x times y plus z. So x is multiplying from the left. So, and what you see, if it will be equal to x times y plus x times z. So if this becomes equal to this, then we know that multiplication is distributed from the left hand side. So let's see. If x is equal to 5, y is equal to 3, and the z is equal to 2, then x times y plus z in bracket will be equal to 5 times 3 plus 2 in bracket. And we know that 3 plus 2 is 5. 5 times 5 is equal to 25. So let's see this. Let's see if it will be equal to this now. So, and our x is 5 and our y is 3. So 5 times 3 is 15. That's 5 times 3 plus 3 times 2. Yeah, 5 times 3 plus 5 times 2. So we have it to be equal to 15. 5 times 3, 15 plus 5 times 2, 10. That is equal to 25. So therefore, x into y plus z is equal to x times y plus x times z. So hence, multiplication is distributed over addition from the left hand side. So we want to look at the right hand side. So let's look at the right hand side now. So in bracket we have y, we have x plus y times z. So this is the right hand side. It's multiplying from the right. So if it becomes equal to x times z, so z times x is xz plus z times y, yz. If this becomes equal to this, then we know it's distributing from the right hand side also. So if x is equal to 5, y is equal to 3, and z is equal to 2, then x is 5 plus 3 times 2. 5 plus 3 is 8. 8 times 2 is 16. So let's look at this now. Here now we have x is 5, z is 2. So 5 times 2 is 10. if x is equal to 5, y3 and the minus z is minus 2. So we have it to 5 into 3 minus 2. So 3 minus 2 is 1. 5 times 1 is 5. So we have the answer to be 5. Equal to, so let's see now. 5 times 2 is 10 minus 5 times 3 is 15. Because this is 5, this is 3. 5 times 3 is 15 minus 5 times 2, 10. 15 minus 10 is 5. So this is equal to this. Thereby, multiplication is distributed over subtraction from the left hand side. And let's look at the right hand side. S minus y multiplied by z. So let's see if it will be equal to xz minus minus yz. So this is 5 and this minus 3. 5 minus 3 is 2 times 2, which is equal to 4. Here, 5 times 2 is 10 minus 3 times 2, 6, which is equal to 4. So, multiplication is distributed over subtraction from both the left hand side and the right hand side. And also distributed over addition from both the left hand side and right hand side. So let's look at division. So we want to see whether division is distributed over addition and subtraction. But here they say that division is distributed over addition and subtraction from the right, but not from the left. So let's see now. We have S, example. We have S divided by y plus z. So let's see whether it will give us equal to this. S divided by z. So yes, S divided by y plus S divided by z. So, and that will give us S divided by y plus z, and the S divided by y plus x divided by z. So you will see, if you look at this now, you see that what we have here is not supposed to be. So, but let's look at the right hand side. S divided by y, so S plus y divided by z. Will be equal to S divided by z plus y divided by z. So division is distributed over addition and subtracted from the right hand side, but not from the left hand side. So what we saw from the left hand side give us not equal to, but what we saw from the right hand side give us equal to. So that is it. Stop. So this is terms and coefficients. Here, an algebraic expression consists of alphabetic characters and numerals linked together with the arithmetic operators. Example: 8x minus 3xy is an algebraic expression in two variables x and y. Each component of this expression is called a term of the expression. Here there are two terms, namely the x term and the xy term. The numerals in each term are called the coefficients of the respective term, so that 8 is the coefficient of x term, and minus 3 is the coefficient of xy term. So if you look at this place now, you notice that we have 8x minus 3xy. So this x is the variable, while the x here is also the variable, and y here is also the variable. So what we have here now is two variables, because this s and this s are like terms, so they are known as 1, and while this y is also a different term, which is y variable. And these numerals attached to these variables are known as the coefficients of the terms. The variables are the terms, and the numerals attached to them are the coefficients. So let's go to the next thing. So what we have here is collecting like terms. This is all about collecting terms that have the same variables together. So terms which have the same variables are called like terms, and like terms can be collected together by addition or subtraction. Example: 4x plus 3y minus 2z plus 5y minus 3x plus 4z. So these are the terms. This is 4x term plus 3y term minus 2z term plus 5y term minus 3x term plus 4z term. And this can be rearranged. So what we do now is we collect the like terms together. So we have 4x here. We say equal to 4x, and we look to see if we can get a term that has x here, just as 4x. So we have minus 3x. So we bring it together with 4x. So we have 4x minus 3x, which is this. So, and the next thing we have here, 3y, that's plus 3y. So we write 3y here. And we check whether we can see another term that has y. And we have plus 5y. So we bring 5y here. So another thing we have is minus 2z. And we look at the similar term. We have 4z here. We have plus 4z. So now we have collected all the like terms. So what we do now, we solve them out using the arithmetic operation, that's addition or subtraction. So what we do next is 4x minus 3x is 1s, and 1s is s. So we have x plus 3y plus 5y is 8y minus 2z plus 4z is equal to 2z. Just as minus 2 plus 4 is equal to minus 2, and minus 2 is equal to plus 2. So now minus 2z plus 4z is supposed to be minus 2z, and minus 2z is equal to 2z, which is plus 2z. So this is what we have, 8x plus 8y plus 2z. So the next thing, another thing we have is this. Four UOV minus 7 UZ minus 6WZ plus 2 UV plus 3WZ. So this can be rearranged by collecting the like terms together. So let's see what we have. We have 4 UV, and the like term we have here is 2 UV. So we bring them together. 4 UV plus 2uv. That's this plus this. And the next we have here is minus 7uz. Minus 7uz do not have any like term here. So we go to the other one also. Minus 6wz. And the like term is 3 plus 3wz. So solving them out now, we have 4uv plus 2uv will give us 6uv. Then minus 7uz. Sorry, 7uz does not have any like term, so bring it down here. 7uz. Then minus 6wz plus 3wz. And in arithmetic operations, minus 6 plus 3 is equal to minus 3. Thus minus 6 plus 3 is equal to minus 3. So now that we have minus 6wz plus 3wz, it will give us minus 3wz. So this is the simple answer. So another thing we have is this 9sy plus 9st minus 3sy plus 4st. That will be equal to, now we have 9sy here, so we bring it down, 9sy. So taking the like term, we have 3sy, that's minus 3sy. As the like term, we bring it here, minus 3sy. And the next thing we have is 9st plus 9st. So as the like term here is plus 4st. Plus 4st. So what we do is 9sy minus 3sy is equal to 6sy. Then 9st plus 4st is equal to 13st. That's plus 13st. So that is it. So we are looking at similar terms. And in the algebraic expression AB plus BC, both terms, like the term AB and the term BC, contain the letter B. And for this reason, these terms, though not like terms, are called similar terms. So, common symbols such as this letter B are referred to as common factors. And by using brackets, these common factors can be factored out. Example, the common factor D in this expression can be factored out to give AD plus BC equal to D into A plus B. That you factor B out since B is common here, these two terms. So you factor it out to have it to be D into A plus B. This process is known as factorization. Numerical factors are factored out in the same way. Example, in the algebraic expression 3pq minus 3qr, the terms are similar, both containing the letter q. They also have common coefficient 3, and this as well as the common letter q can be factored out to give 3pq minus 3qr. So you factor 3qr because they are common in this expression. We have 3 here because 3 is the coefficient of the term. So we have 3 here and we have 3 here. So we have to bring it out here. So we have q here, we have q here. So bring 3q out. So that when 3q multiply p, it will be 3qp. And when this 3q also multiply minus r, it will be 3q minus r. That's minus 3qr. So let's look at this exercise. So exercise 1. So simplify the algebraic expression. Nine st minus 3sv minus 6sw. So here now, you will notice now, for you to be able to simplify this, first of all, you will notice that in this expression we have 9 as the coefficient of st term, and we have minus 3 as the coefficient of sv term, and we have minus 6 as the coefficient of sw term. So these 3 coefficients now, we look for the LCM, 9, 3, 6. So, and 3 is the LCM, so we bring out 3 here. LCM of these 3 here. So, and we look into these 3 terms now. We see that S is common in all these terms. So we bring out S. So, and before you factorize something, you have to use brackets. So to factor it out, so we put bracket. So now we have 3 here now. So 3 T, and this one is will become minus SV. Sorry, minus V, because we have 3s outside, and this one will become minus 2W. So that when this 3 goes to this, 3s times 3t, that's this, minus 3s times v, this will give you this, minus 3s times 2w, and this will give you this. I'm going to factor this out. So that's it. So let's go to the second exercise. Exercise 2. Exercise 2 says, simplify the algebraic expression. HQ plus 3HP plus 5 intel 5 intel. So here now we notice that in these 3 expressions we have H here, we have H here, and there is no similar term here. So what we do now is we bring out the common term here. So we factor it out to be H, H here. So we have H here plus 3HP in bracket, so 1 plus 5 intel. So for this one, we factor H out to be H into Q plus 3P. then here plus 5 enter. So if you look at this expression, you notice that there's no way we can put this 5 enter inside this bracket, because this 5 enter does not have anything common with this expression, with this ones here. So it has to be outside. So these ones that have something in common, we put them here and factor out that thing that made them to be common, which is h. So exercise 3. Exercise 3, which is the last exercise for this expression. Exercise 3. We have this simplify the algebraic expression. DC plus AC. So this expression, we have C, and C is a common term between these two expressions. So, or let's say common factor. So I have to factor it out using a bracket. So what we do now is bring out this C outside, then bracket D plus A, so that we have C times D plus C times A. That's it. C times D will be DC. That's C times D will be DC plus C times A will be AC. D plus A. So there we are solving this expression. So what we want to look at now is expanding the bracket. Expanding the bracket. Sometimes it will be desired to reverse the process of factorizing an expression by removing the bracket. So this is done by A, multiplying or dividing each term inside the bracket by the term outside the bracket. But B, if the term outside the bracket is negative, then each term inside the bracket changes sign. Example, the bracket in the expression 3x into y minus 2z in bracket are removed to give 3xy minus 6xz. That's 3x multiplied y multiplied by 3x will give you 3xy minus 2z multiplied by 3x will give you 6xz. And the bracket in the expression minus 2y into 2x minus 4z. So if you look at this now, that's what they told us here, that if this expression outside the bracket is negative, then all the expression inside the bracket will change sign. So this expression now I remove to give minus 4xy plus 8yz. Example, y plus x over 8x minus y minus x over 4x is an alternative form of y plus x divided by 8x minus y minus x divided by 4x, and the bracket can be removed as follows. So let's look at how to remove the bracket. So here now, we have y plus x in brackets. Y plus x divided by 8x minus we have y plus x in bracket divided by 8x minus in bracket y minus x divided by 4x. So we want to look at how to remove this bracket now. So here I have y plus x. So that will be our numerator. Y plus x and divided by s is the denominator. 8x minus here y minus x is our numerator and divided by 4x as well, denominator. So this will give us y, because here now this is two expressions. Well, they look to be one because they have common denominator. So let's split them. So y, we have y over 8x plus x over 8x. That's for this expression. Minus y over 4x minus x over 4x. So that will give us, so here you collect the like terms. We have x over 8x here, and we have 4 over, we have x over 4x. So we bring these two together. This x over 8x and minus x over 4. So let's look at how to remove the brackets. So in bracket we have y plus x divided by 8x outside the bracket minus in bracket y minus x divided by 4x. So we want to see how to remove this bracket now. So here now we have this to be the numerator, y plus 8x divided by 8x minus this one, y minus x divided by 4x. So when you look at this expression now, you notice that this place now, this is two expressions in one. Why is it so? Is because they have common denominator, so we have to split them. So that is to be x over 8x plus x over 8x minus this one, y over 4x minus x over 4x over 4x. So let's solve this one out. So sorry, collecting the like term. So collecting the like terms, we have y over 8x here, y over 8x here, and we have y over 4x here. That is minus y over 4x. That is y over 8x minus y over 4x. So we cross multiply. Since they are denominator are not the same, so we have to cross multiply them. And so that will be 4x times y equal to 4xy minus 8x times minus y, that will be equal to minus 8xy. So 8x times 4x will give us over 32x squared. So 4xy minus 8xy. 4 minus 8 will give us minus 4. That's minus 4xy over 32x squared. So this x squared will be divided by this x. This will cancel out this. So to give us minus 4y over 32x. So then, how many we have to bring it to the lowest term. So how many 4s do we have in 32? We have 8. So we have it to be y over 8x. So this is what we've got, minus y over 8x for this now. So let's look at the other two terms, similar terms. So these ones now, we have x over 8x minus x over 4x. So we cross multiply since they do not have common denominator. So now, no, not cross multiplying. So what we do now is we divide this 2x. So this x will divide this x, and this x will divide this x. So what we have here now is x divides x, so 1 will be left here. So we have it to be equal to minus y over 8x, which is this, plus 1 over 8. 1 over 8 minus 1 over 4. Then we still have to cross multiply. So this times this will give us 4 over 8. And this times this will give us, that's 8 times minus 1 will give us minus 8 is common here. So we factor 8 out. 1 over 8 into 3 minus y over x. So this is the answer, and this also is the answer. Or we can say 1 over 8 into 3 times x. 3 times x is 3x minus y. That's 3 times this, 3x minus y. That's what we got here. So this is the answer. Yeah. So we are looking at nested bracket. Whenever an algebraic expression contains brackets nested within other brackets, the innermost brackets are removed first. Example, so if you look at this expression now, you see that we have this bracket within these two other brackets. So we want to solve this problem now. We start by removing this innermost bracket, followed by this one, then before this. So let's solve it out now. That will be equal to, so 5 minus 5 times b, minus 5 times b, minus, and also minus 5 times minus 3a. So we have it to be 7 into a minus 4. So a minus 4, so minus 5 times b will give us minus 5b, and minus 5 times minus 3a, because minus times minus is plus. So minus 5 times minus 3a will give us plus 15a. So the next thing we'll do now is to remove this one, this bracket. So here now, but before this bracket, we notice that there is a minus sign immediately before the bracket. So this minus sign will multiply everything in this bracket. So 7 times minus 4 give us minus 28. 7 times 5b, that will be 35b plus 35b. And 7 times minus 15, that's a minus 105a. 7 times minus 15 is minus 105a. So here now, we have to collect like terms. 7a here and the 105a are like terms. So we'll carry this over to this place. So we'll have this to be, we'll carry these two to this place. So we'll have then plus 28. So 35b, then now we are carrying this to this place now. So minus 105a. Or let's take it one after the other. So 35b minus 105 plus 7a, then minus 28. So we have 35b then minus 105. Minus plus is minus. So when you say minus 105 plus 7, that will give us minus 28. So this is the answer. And the second lesson. So now, so this is the algebraic expression for 2x plus 3, then 5 minus 2 into x minus y. So we have to simplify. So here now, we take the innermost bracket first. So what we will do now is minus 2 times x. First of all, let's come 4 into 2x plus 3, 5. Then minus 2 times x is minus 2x. Then minus 2 times minus y. Minus times minus is plus. So minus 2 times minus y will give us plus 2y. So if you look at it now, you see that this innermost bracket is gone. So let's take this bracket now. So this 3 multiplied everything in this bracket. So 3 times 5, 15. 3 times minus 2x minus 6x. 3 times 2y give us plus 6y. So the next thing now, let's multiply 4 through all this. So 4 times 2x. 4 times 2x gives us 8x. Then 4 times 15 plus 4 times 15 will give us 60. Then 4 times minus 6x, that will be minus 24x. Then 4 times 6y will give us 24y. So now we collect the like terms. Here we have 8x. So let's look for another term that have x. So we have 24x here, which is like, that's minus 24 is like term. So we bring it to this place. That will be 8x minus 24x. And the next thing, we have 24y. And 24y do not have any like term. Plus 60. Now equal to 8x minus 24x will be equal to, let's bring it this way, 24y plus 8x minus 24x plus 60. So then 24y plus 8x minus 24x. 8 minus 24 is equal to minus 16. So we have it over here. 24y minus 16x plus 60. So that is the answer.